Hey guys, so as requested by some of my followers, I've tried to compile this predicted paper for AQA Level 2 Further Maths Paper 1, which is a non-calculator paper. So I looked at the trend of questions starting from 2020 till 2024, and based on the type of topics that were repeated and the ones that skipped a year, so I compiled this paper. I tried to add as many topics as I could for a revision. So most of these questions are like from the past paper. For some, I tweak them a little bit to include like as many things about the topics as possible so that everything is revised through this paper. You can easily access this document in my Google Drive. I'll share the link in the description through which you can download this. And on this document, you can also find my QR codes for my Instagram, TikTok, and YouTube page. If you like this video, if you understand the concepts better through this video, please subscribe and like this video. And I hope this video helps you out with exam prep. So without any further delay, let's start the questions. So simultaneous equations is something that comes every year. Sometimes they give like two equations. Sometimes they give three equations. So the three equations is more frequent compared to the two one. And I chose the one that was the most difficult one. So through this, you will have like better practice for solving a simultaneous equation. So let's start with this one. So in these type of questions, it's best to choose two equations through which you can eliminate two variables and then use that to find the value for the other variables. So what I'm going to do is I'm going to take the first equation and I'm going to times this by 3. When I times this by 3, what happens is that I get an equation which is going to be 6a plus 3b minus 3c equals to 24. Now, if you notice, the third equation also has a 6a, a 3b, and then we have plus c equals to 0. If we subtract these two equations, what happens is that a and b get eliminated. So then we're just left with c, and we can easily find the value of c. So now if you subtract the two, that's 0 plus 0 minus 4c, because negative 3c minus c equals to 24. C equals to 24 over negative 4, and c is negative 6. So we can split the value of c in the second and the first equation to figure out the value of a and b. So 2a plus b minus negative 6 equals to 8, which is going to be 2a plus b equals to 8 minus 6, and that's 2. And then for the second equation, 4a minus 3b minus 2 times negative 6 equals to negative 9. That's 4a minus 3b plus 12 equals to negative 9. That's going to be 4a minus 3b equals to negative 21. So we have this and we have this. We can solve these two equations simultaneously to find the value of a and b. So 4a minus 3b equals to negative 21. 2a plus b equals to 2. Multiply the second equation by 2. So that's 4a plus 2b equals to 4. If we subtract the two equations, so 4a minus 3b equals to negative 21, and then 4a plus 2b equals to 4. Subtract them. So that's 0 for this. Negative 3b minus 2b is negative 5b, and that's negative 21 minus 4, negative 25. So b is 5. So a is going to be 4a plus 2 times 5 equals to 4. 4 minus 10, and a is negative 3 over 2. So a is negative 3 over 2, b is 5, and c is negative 6. This is how you can solve your simultaneous equations. If you use another way, that's completely fine. It doesn't matter which method you use as long as you're able to get to the solution. There might be a possibility that I might be using a different method compared to you. that's completely fine. So don't get confused if I do something else and you are doing something else. Then it says rationalize and simplify fully. 5 root 3 plus root 5 over root 3 minus root 5. So rationalizing surds comes very commonly every year. So you need to know how to solve these questions. So when we're rationalizing a surd, basically what we're doing is that we are multiplying and dividing the fraction by the conjugate of the denominator. So conjugate of root 3 minus root 5 would be root 3 plus root 5. So you multiply and divide the fraction by this. Always it's going to be the denominator getting multiplied and divided by the fraction, but with the opposite sign. So if it's minus in the middle, you put plus. If it's plus, you put minus. So that's one thing you need to remember about this. The other thing is that when you multiply the numerators and the denominators with each other, so we have 5 root 3 plus root 5 times root 3 plus root 5. And then in the denominator, we have root 3 minus root 5 times root 3 plus root 5. So if you notice, the denominator is basically difference of perfect squares. So in difference of perfect squares, a square minus b square equals to a minus b times a plus b. This is exactly what's happening over here. A is root 3 and b is root 5. So what we can do is we can just rewrite the denominator as root 3 squared minus root 5 squared. Now for the numerator, we expand the bracket. 5 root 3 gets multiplied with root 3, then with root 5. And again, root 5 gets multiplied with root 3 and root 5. For the denominator, square of a root is the number in the root, so that's going to be 3 minus 5. So 5 root 3 times root 3 is 5 times root 3 squared plus 5 times root 15, because 3 times 5 is 15 and the 15 goes in the root. This will be root 15 again, and this is going to be root 5 squared over negative 2. Going to be 5 times 3 plus 6 root 15. When we're adding or subtracting roots, you need to remember that the number inside the root has to be the same. If it's not the same, then you cannot add or subtract them. And square root of root 5 is 5. This then simplifies to 15 plus 5 plus 6 root 15 over negative 2, which is 20 plus 6 root 15 over negative 2, which becomes negative 10 minus 3 root 50. That is your final answer. So two things. First is that you're multiplying and dividing the fraction by the conjugate of the denominator. So in the conjugate, the sign in the middle will be different. If it's negative in the denominator, you add a positive when you're multiplying and dividing the same thing by the fraction. Second thing is difference of perfect squares. When you are multiplying the brackets in the denominator, they're always going to be simplified using difference of perfect squares. That's like a given thing. So if you remember difference of perfect squares, you can easily make your calculation simple by directly applying that instead of expanding the brackets in the denominator. In the numerator, you will have to expand the brackets, so you can't skip that. And then when you're squaring a surd, your square and root get cancelled out, and what you're left with is the number inside the square root. So that's what happened with square root of 3 being squared, that gave us a 3, and same for square root of 5, which gave us a 5. And apart from that, if you're adding or subtracting surds, the number inside the root has to be the same. Otherwise, you cannot add or subtract them. Then rearranging formula, that comes very frequently in paper 1. So right now, the subject of the equation is t, we have to make w the subject. Now remember, we need to make w the subject, not w cube. So you need to be very careful about this. So first, we cross multiply to get rid of the fraction. It's going to be t times w cube minus 2 equals to 3 w cube plus a. Expand the bracket. T w cube minus 2t equals to 3 w cube plus a. Since w has to be made the subject, collect the terms with w on one side. So t w cube minus 3 w cube equals to a plus 2t. Take w cube common so that there's only one w. So it becomes w cube times t minus 3 equals to a plus 2t. Now bring the t minus 3 on the other side, so it becomes a plus 2t divided by t minus 3. Now this is w cube equals to the fraction. We need to make w the subject, so I'm going to take the cube root on both sides. So w equals to cube root of a plus 2t over t minus 3. That is your final answer. Then sine rule. So like for this question, I noticed that one year they gave cosine, and then the other they gave sine, and then cosine, and sine. They like it was like alternate actually, like sometimes sine, sometimes cosine. So for you to solve these questions correctly, you need to be familiar with both your sine and cosine rules. So for the cosine rule, you need to remember that that is only applicable when you have two lengths and the angle between them. So you need to know the formula for cosine rule. And the best thing about these questions is that they tell you in the question what you need to apply. At least for the cosine rule, they always say like, use the cosine rule to solve this question. Over here, they said that work out the value of sine theta. So they did say that you have to use the cosine rule, which means that you go to the next option, which is the sine rule, because we cannot use Pythagoras or trigonometry because it's not a right angle triangle. So you need to be very careful with the formulas. You need to know the conditions for each formula. And then based on those conditions, you decide which one is the best option in the given question. So to work out the value of sine theta, they have told us that in a triangle RST, RS is to ST is 1 is to 4. So if RS is, let's say, X, ST is going to be 4X. So if we look at the given information, we have the angle R and we have the side opposite to angle R, which is 4X. We have to find sine theta, theta is angle T, and we have the side opposite to that, which is X. So using this information, we can figure out what the value of sine theta is going to be. And for that, we're going to use the sine rule. So for sine rule, remember that what you need is one angle and its opposite length. So if that pair of angle and length is given, you can easily find the other information using sine rule. So over here, we're going to take ST as given, which is 4X, and RS is X. So 4X would equal to sine of 135, which is equal to X over sine of theta. So if we write 4X over X equals to sine 135 over sine theta, you can see that the X is getting cancelled out. It's 4 over here. Now for the value of sine 135, you need to know that sine 135 comes over here in the second quadrant. Sine 135 is the same as sine 45. So sine 135 is the same as sine 45. So to find the value of sine 45, you need to remember your special triangles. And your special triangles, the 45, 45, 90 triangle. So that means this length is 1, this is 1, this is root 2. So sine 45 would be 1 over root 2. So you can just replace sine 135 with 1 over root 2. So 1 over root 2 divided by sine theta. Now to find the value of sine theta equals to 1 over root 2 divided by 4, which is 1 over 4 root 2. Let's rationalize this. So we times it by root 2, and that's going to be root 2 over 8. So sine theta is equal to root 2 over 8. That is your answer. So for this question, you need to know your exact values of the trig ratios. You need to know the conditions for sine rule. You need to know the conditions for cosine rule. You need to know how to apply those trig values. You can also use the special triangles. Whichever is easier for you to remember, just use that. And then you plug in the values and simplify the equation, and it will easily give you the value that's required. So for differentiation, I chose this question because I wanted to include two things in the same question, where we're expanding brackets and then differentiating, and then we have a fraction as well. So with the help of this question, you'll be able to learn everything that you need for like basic differentiation and the type of questions that frequently come for the basic differentiation. So first, whenever we have a fraction and the variable is in the denominator, what we do is we split it into two fractions first. Like in this case, we will write 4x cubed over x to the power of 4 plus x to the power of 7 over x to the power of 4. And over here, I'm going to expand the bracket. So it's going to be 2x to the power of 5 minus 7x to the power of 4. So for the fraction, we know that when we're dividing similar bases, we subtract the powers. So that means it's going to be 4 over x. This is going to be x cubed. And this remains as it is. Now, the x is in the denominator. What you will do is you will bring it in the numerator, and what happens is that the power becomes negative. So it becomes 4 times x to the power of negative 1, and everything else is as it is. Now you differentiate this. So dy by dx is going to be negative 4 times x to the power of negative 2 plus 3x squared plus 10x to the power of 4 minus 28x to the power of 3. When you're differentiating, you bring the power down and multiply it by the coefficient. And then what we do next is we subtract 1 from the original power. So when I brought the negative 1 down, negative 1 times 4 became negative 4, and negative 1 minus 1 became negative 2. Similarly, 3 becomes down, so it's 3x, and 3 minus 1 is 2. 5 times 2 is 10 minus 1 from the power, and then 4 times 7, 28, and then minus 1 from the power. So this is your basic dy by dx for the given equation. Straight lines. So they've given us two equations for straight lines, and they're asking us if they're parallel or not. So for straight lines, you need to remember there are two types. Either they're parallel or they're perpendicular, or like there's no link between them. So for the parallel lines, the gradient is always same. M1 equals to M2. M is the gradient. And for perpendicular lines, your M1 times M2 will equal to negative 1. So these are the two conditions you need to know for parallel and perpendicular lines. So when we're trying to prove if both lines are parallel or not, we convert the equation into slope-intercept form, which is y equals to mx plus c. So for the first equation, it will be y equals to 2x plus 3. Just take 2x to the other side. And for the other equation, we divide both sides by 9 to make y the subject. Is going to be 18 over 9x minus 5 over 9, which is y equals to 2x minus 5 over 9. We can clearly see that the gradients are same. M1 is 2, M2 is also 2. So since the gradients are same, that means they are parallel. Then it says that we have 2 points S and T, where S has the coordinates of 7, 2, and T has the coordinates of 5, negative 4. These 2 points lie on a straight line. We need to work out the gradient of the line. So simple, use the gradient formula, which is y2 minus y1 over x2 minus x1. So negative 4 minus 2. If you say this is x1, then this is y1, and this is x2, and this is y2. You can call S as x2 and y2 as well, but you need to make sure that x1 and y1 are together and x2 and y2 are together. So negative 4 minus 2 over 5 minus 7. So that's going to be negative 6 over negative 2, and that's positive 3. So your gradient for the line connecting S and T is 3. Then it says work out the distance between S and T. Give your answer in the form of A root B, where A and B are both integers greater than 1. So coordinates of S are 7 and 2 and 5 and negative 4. So distance formula is root of y2 minus y1 whole square plus x2 minus x1 whole square. So that's going to be negative 4 minus 2 squared plus 5 minus 7 whole square. So that's negative 6 squared plus negative 2 squared. That's 36 plus 4 root 40, which we can simplify to 2 root 10. How? 40 splits into 4 times 10. 4 is a square number, which is 2 times 2. So 4 comes outside as 2 and the 10 remains inside the root because we cannot further simplify it. So 2 root 10 is your distance. Now as you can see, A, which is 2, that's greater than 1, and B, which is 10, that's also greater than 1. So next we have functions. So we have two functions, f of x equals to x squared minus 10 for all values of x, and g of x, which is x minus 2a times x minus 3 for all values of x. We have to work out the value of f of x equals to 6. So very simple, you put the function equal to 6, bring the 10 to the other side, that's 16. Then we square root both sides to find the value of x, which is going to be plus minus 4. So x is positive 4 and x is negative 4. Then write down the range of f of x. So f of x was x squared minus 10. If you remember your basic quadratic function, that's y equals to x squared. We have x squared minus 10, which means our graph is 10 units down at negative 10. So doesn't that show that our graph is starting from negative 10, like that's the minimum value, and then it's, increasing on both sides of the curve? So that means our range is going to be greater than or equal to negative 10. That is your answer. Then g of 0 is 24. Find the value of a. G of x was given as x minus 2a times x minus 3. So x is 0 over here, where g of x is 24. So 24 equals to 0 minus 2a times 0 minus 3. That's 24 equals to negative 2a times negative 3, which is 6a. 24 divided by 6 is a. That gives us 4 equals to a. Then it's saying find g of f of 3. So first let's find f of 3. F of 3 is going to be x squared minus 10. So 3 squared minus 10, and that is negative 1. Now we put negative 1 into g of x because it was g of f of 3. So f of 3 was the domain of g of x. And the value of f of 3 is -1. So now -1 becomes the domain of g of x. So that's going to be -1 minus 2. A was 4, so you replace a with 4 times -1 minus 3. So that's -9 times -4, and that's 36. That's your answer. And then the function h is given by h of x equals to 4 minus x over 2. We have to work out the inverse. So you must have noticed that I mixed up a few questions in this one, and I included both composite functions, inverse function, and then finding the basic domain and range for, the given functions, so that you have a good grasp of all of the concepts for the functions topic. So you begin with replacing h of x with y equals to 4 minus x over 2. Right now, y is the subject. We have to make x the subject. So cross multiply and then swap x with 2y. So x equals to 4 minus 2y. Now the last step is to replace x with h inverse x and y with x. That's your inverse. Once again, you must be doing some other method. That's also fine. There's no issue with that. Just remember, the whole point is to get the correct answer. And if you're getting the correct answer, it's all good. Now for this, we have an algebraic identity where it's 8x squared plus 20x plus n on the left-hand side and c times x plus d whole square plus 3, where c, d, and n are constants. You need to work out the value. So this question includes two things: completing square form and identities. But not trigonometric identities, the algebraic identities. So for this, what I'm going to do is I'm going to use completing square method on the left-hand side and turn that into the right-hand side and then compare what c, d, and n would be. So first thing, always make sure that the coefficient of x squared is 1. Right now, the coefficient of x squared is 8. So first step is to take 8 common from the left-hand side. So that's going to be x squared plus 20x over 8 plus n over 8. This was the first step. We can simplify the 20 over 8 as 5 over 2 as well. Now, you must know that a complete square looks like either a plus b whole square or a minus b whole square. Since it's x squared plus 20 over 8x, that means it's a plus b whole square. Now, a plus b whole square expands to a squared plus 2ab plus b squared. So if we compare this with our square, we have the a square, which is x squared. We have the 2ab, which is 5 over 2x. What we need is our b square, because n over 8 is not our b square value. We need to find that to complete the square. So if we put 2ab equal to 5 over 2x and replace the a with x because that's what a is, we can see that b equals to 5 over 4. So which means we can write x squared plus 5 over 2x plus 5 over 4 square, which is the b square, but we will do minus 5 over 4 square as well. The reason why we're doing minus 5 over 4 square as well is because when we're introducing something new in the equation, like if we're adding something new, we subtract it as well. Similarly, with fractions, if you multiply randomly something by a number when you're making the denominators equal, you divide the fraction by it as well. So it goes both ways. If you're adding something new, you subtract it as well. So if you're adding 5 over 4 whole square, you subtract 5 over 4 whole square as well. So now when we rewrite this as the bracket, it's going to be 8 bracket x plus 5 over 4 whole square. This is your complete square now. And this minus 5 over 4 whole square plus n over 8 comes outside the bracket as negative 25 over 16 plus n over 8. Now we multiply the 8 with the bracket and these fractions. That's 8 times x plus 5 over 4 squared minus 25 over 16 times 8 is 25 over 2. And n over 8 times 8 is n. So we can clearly see that C is 8, D is 5 over 4. And for the value of n, what we do is we put negative 25 over 2 plus n equal to the 3. So 25 over 2 plus n equals to 3. N is 3 plus 25 over 2. And that gives us 31 over 2 as the value of n. You can write it as a mixed number or as an improper fraction. Either way, it's going to be fine. So that's how you find your missing values, and that's how you use completing square as well to turn the quadratic equation into completing square form. Let's just simplify 8x cubed minus 50x over 2x times 6x squared minus x minus 35. Give your answer in the form of ax plus b over cx plus d, where a, b, c, and d are integers. So for algebraic fractions, there are several types of questions you can come across in past papers. Sometimes they're adding fractions with unlike denominators. Sometimes they're asking you to simplify a fraction. So you can get any option. But what I saw was in 2024, they gave a similar question like this. Also, if you're able to solve the difficult question, you will be easily able to solve the simpler one. So let's start with this. So we have 8x cubed minus 50x over 2x times 6x squared minus x minus 35. So we first see if there's anything common in the numerator. Both 8 and 50 come in the 2 times table, and we have x with both the terms as well. So we can take 2x common. So that leaves us with 4x squared minus 25 in the bracket. And over here, it's 2x bracket 6x squared minus x minus 35. So we can easily cancel out the two x's. And over here, if we notice, 4x squared minus 25 is difference of perfect squares again. 4 is a square number, x is being squared, and 25 is a square number as well. So we can rewrite that as 2x plus 5 times 2x minus 5. And for the denominator, we have 6x squared minus x minus 35. Now, the denominator is a quadratic equation, which also needs to be factorized. You can factorize it using the completing square or the quadratic equation, whichever is easier for you. I'm going to use splitting the middle term. So for splitting the middle term, we have to multiply the coefficient of x squared with the constant. So 6 times 35, that equals to 210. Now we need to find factors of 210, and we have to pick that sort of factor, which when added or subtracted, give us the middle term, which is 1 over here, because x has a coefficient of 1. So that is basically 14 times 15, because 15 minus 14 is 1. So we can write 6x squared as it is, and the negative x becomes negative 15x plus 14x minus 35. So 2x plus 5 times 2x minus 5 divided by, we split the equation into two groups and we factorize those groups separately first. So between 6x squared and 15x, we have 3x common. So 2x minus 5 in the bracket. And between 14x and 35, we have 7 common. Again, 2x minus 5 in the bracket. So that's 2x plus 5 times 2x minus 5 over 2x minus 5 times 3x plus 7. Since both 3x and 7 had 2x minus 5 multiplied to them, so we took the 2x minus 5 common and put the 3x plus 7 in another bracket. We can see that 2x minus 5 is getting cancelled out, and we're left with 2x plus 5 over 3x plus 7 is our final answer. So based on this, our A value is 2, B is 5, C is 3, and D is 7, and all four are integers. Then the nth term of sequence. So they've given an nth term of a sequence, which is 3n squared over n squared plus 2. One term in the sequence is 32 over 11. Work out the value of n. So we just put the equation equal to 32 over 11 because that's one of the terms in the sequence. And then using this, we can find the value of n. So if we cross multiply, 32 times n squared plus 2 equals to 3n squared times 11. 32n squared plus 64 equals to 33n squared. Collect the n squares on one side. So 33n squared minus 32n squared. That's n squared. Square root both sides, and n equals to plus minus 8. Now, obviously, your number of sequence cannot be negative numbers, so we just take positive 8 as the answer. Then write down the limiting value of the sequence as n approaches infinity. So for the limiting value, what we do is we take the highest power for the variable, which is n squared, and we take the coefficients of those and divide them. So basically, you start with 3n squared divided by n squared. The n squares get cancelled out, and we're left with 3. So the limiting value of the sequence is 3. Then says the point P lies on the circle x squared plus y squared equals 16. The line OP is at an angle 60 degrees to the positive x-axis. We need to show that the coordinates of point P are 2 and 2 root 3. So if we connect this with the axis, we can see that this is a right angle triangle. So in the equation of a circle, the x and y value give us the origin, which is 0 over here. And this is your radius square. So that means radius is root of 16, and that's going to be 4. So this distance is 4. If you look at the right angle triangle, one angle is 60, one is 90. So this is going to be 30. And if you remember your special triangles, the 30, 60, 90 ratio, if the length opposite to the right angle is 4, then the length opposite to 30 degrees is going to be half of it, that's 2. And the length opposite to 60 degrees is going to be 2 root 3. So now based on that, we can see that this value is, since this distance is 2 root 3, this value is also 2 root 3, was starting from the origin. And since this distance is 2, this is also 2. So this shows that the coordinates of P are 2 and 2 root 3. Then says work out the equation of the tangent to the circle at P. Write your answer in the form of x plus ay equals to b, where a and b are constant. So for the tangent, you need to remember that if I draw a tangent at P, your tangent is always at a right angle with the radius. And OP is the radius, we know that. So that means whatever is the gradient of OP, we can use that to find the gradient of the tangent, and then use that and the coordinates of P to figure out the equation for the tangent. Always remember that your radius and tangent will always be at right angle in a circle. So we begin at finding the gradient of OP. So MOP is going to be 2 root 3 minus 0 over 2 minus 0, which is root 3. So like we said, for perpendicular lines, the product of the gradients equals to -1. So MOP, which is the gradient of the line OP, times the gradient of tangent equals to -1. So root 3 times MT equals to -1, and MT equals to -1 over root 3. So using the point slope form or the slope intercept form, either of the equations, we can use that to find the equation of the tangent. So if I use point slope, it's y minus y1 equals to m times x minus x1. y1 is 2 root 3. M is -1 over root 3. And x1 is 2. we're basically using the coordinates of P, 2 and 2 root 3. So now that we've substituted the values, we just need to simplify the equation. We cross multiply to get rid of the fraction. So that's root 3y minus 2 root 3 squared equals to negative x plus 2 root 3y minus 2 times 3 equals to negative x plus 2 root 3y minus 6 plus x equals to 2. So that's going to be root 3y plus x equals to 2 plus 6. We want the constant on the right-hand side, so move 6 to the right-hand side. And root 3y plus x equals to 8. This is your final equation. So key point over here is to remember that the gradient of the radius and tangent are not going to be equal because they're not parallel. They're perpendicular to each other, which means the product of the gradients will always equal to -1. And you can easily use that to find the unknown gradient. Then for matrices, we have two matrices being multiplied and the result equals to Ki, where K is a constant and I is the identity matrix. We have to work out the value of A and B. So I noticed that in the 2024 one, they already gave the reflection, the transformation one. So I thought like they wouldn't give the exact same thing again because for the matrices one, I've noticed they do it like they skip the transformation like for 1 year or something. So based on that, I put the multiplication one and not the transformation one. But if you think you don't know the transformation one and you still need to revise it, I would suggest going through one of the possible questions for that and making sure you know how to reflect a matrix in y equals to x and y equals to negative x, or like, if it rotates 90 degrees or 180 degrees. So for this one, we will multiply both the matrices. So that's going to be 2 times A plus 1 times 0. Remember, it's row multiplied by column. So it's 2 times A plus 1 times 0. Then we do 2, 1 times B, 0.4, the next column. So that's going to be 2 times B plus 1 times 0.4. And then we repeat the same steps for the second row. So 0 times A plus 3 times 0. Then 0 times B plus 3 times 0.4. This equals to K times I. So that's 2A. This is 0. This is 2B plus 0.4. And this is 1.2. Now, I is the matrix. One, 0, 0, 1. So 2A equals to K. 1.2 equals to K. And 2B plus 0.4 equals to 0. So if K equals to 1.2, that means A equals to 1.2 over 2, which is 0.6. And B is going to be negative 0.4 over 2, which is negative 0.2. So based on this, we can say that 2 times 0.6 is 1.2. 2 times negative 0.2 is negative 0.4 plus 0.4, that's 0. This remains 0 and this is 1.2. So that means your K is 1.2 over here. And that proves the identity given in the question that the matrices being multiplied equals to K times A, and K is 1.2. Then a quadratic sequence starts with -2, -1, 430. We have to work out an expression for the nth term. So let's begin at finding the second difference. So -2, -1, 4, 30. First difference is going to be 1, 5, and 9. Second difference is 4. So what we do is we Multiply the second difference by n square and divide it by 2. So that gives us 2n square. This is a part of the nth term for the quadratic sequence. We use this 2n square to figure out what the rest of the nth term equation is going to be. So what we will do is we will create a table, and we're going to use this table to figure out the complete nth term expression. So we will write the original terms, OT. We will write 2n square terms, and over here we will write OT minus 2n square terms. So original terms are -2, -1, and 4. I'm going to skip 13 because we can easily figure out the values from the first three terms as well. And since the calculator isn't allowed, so we need to make the calculation quicker and simpler. 2n squared is going to be 2 times 1 squared is 2, 2 times 2 squared is going to be 8, and 2 times 3 squared is going to be 18. So now if we subtract the original term from the new term, -2 minus 2 is -4, -1 minus 8 is -9, and -4 minus 18 is -14. So now we use this sequence over here to find the rest of the nth term expression. So using this, we can see that the common difference is -9 minus -4, and that's -5, which means the nth term for this sequence is going to be -5n plus 1. So the complete nth term is 2n squared -5n plus 1. That is your final answer. So first, you find the common difference, times it by n squared, and then divide it by 2 to get the first part of the nth term of the quadratic sequence, which will be the n squared term. Then you use that to create another sequence, subtract the original sequence and the new one to create a new sequence. And then using that new sequence, you create your expression for the linear part of the quadratic equation. And then you just add it to the quadratic part, and that gives the complete nth term equation for your quadratic sequence. Then a different quadratic sequence has the nth term n squared plus 10n. Use an algebraic method to work out how many terms in the sequence are less than 2000. Do not use trial and improvement. You must show your working. So n squared plus 10n is less than 2000. So we collect the terms on one side, which is the left-hand side. To solve this quadratic equation, once again, you can use the quadratic formula or splitting the middle term. I'm going to use splitting the middle term. I need to find factors of 2000, which when added or subtracted give us 10, and that's 50 and 40. So n squared plus 50n minus 40n minus 2000 less than 0. Factor by grouping, the first two terms make one group, the last two terms make another group. So in the first group, we have n common, so n plus 50 over here. And the last group, we have -40 common, so n plus 50 again over here. N plus 50 is common between n minus 40. So n is between 40 and 50. We have to find how many terms in sequence are less than 2000. So obviously, -50, sorry. So obviously that's going to be 39 because it's supposed to be less than 40. So that's 39. And it cannot be a negative number because the number of sequence cannot be negative. So 39 it is. Then for binomial expansion says that the quotient of the x to the power 4 term, the expansion of 2x plus a to the power of 6 is 60. We have to work out the possible values of a. So binomial expansion has the expression of NCR times a to the power of n minus r times b to the power of r. A over here is 2x, b is a. So we need to create an expression for the x fourth term. So that means 2x to the power of n minus r times a to the power of r and ncr. So n is 6. X needs to have a power of 4, which means r would be 2. So 6c2 times 2x to the power of 6 minus 2 times a to the power of 2. Now, NCR is the same as n factorial over r factorial times n minus r factorial, which in our case is going to be 6 factorial over 2 factorial times 6 minus 2 factorial. If you have learned another way to solve this, please use that. You don't need to use the factorial method. There's no compulsion. But if you use the same way, then this is your opportunity to learn how to use it. So 6 factorial is basically 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 6 minus 2 is 4 factorial. So that's going to be 4 times 3 times 2 times 1. Factorial is basically, if I write this over here, 3 factorial. That's basically 3 times 2 times 1. So you go in descending order and you're multiplying all of the numbers until you reach 1. So that's what we did over here, 6 times 5 times 4 times 3 times 2 times 1. And same for 2 factorial, which is 2 times 1. And then for 6 minus 2, which is 4. So 4 factorial is 4 times 3 times 2 times 1. So now you can see that we can cancel out this. This becomes 3 and we have 15 over here. So 6c2 is 50. So 15 times 2x to the power of 4 times a square is 60x to the power of 4, because the coefficient of x to the power of 4 is 60. So 2 to the power of 4 is 16. So 15 times 16 x to the power of 4 a square equals to 60 times x to the power of 4. So the x to the power of 4 gets cancelled out. So we have 15 times 16 times a square divided by 60 equals to 1. So that's 5. And that's 20. And that's 5 again. And that's 4. So a squared equals to 1 over 4. Square root both sides. And a equals to plus minus 1 over 2. These are your possible values of a. Then it says that F, H, K, and G are points on a circle. Chords H, J, and K, F intersect at L. E, F, G is a tangent to the circle. F, H, and J, K are parallel. Angle F, H, J is 2x. Give reasons why angle F, K, J and angle H, J, K are also equal to 2x. So F, K, J is this one. And H, J, K is this one. The reason why F, K, J is equal to 2x is because angles in the same segment. They're from the same segment, that's FJ, so angles from the same segment are always equal. Then for HJK, that's also 2x because we have two parallel lines and these two angles are alternate angles. So alternate angles are equal. So this is your reason for the two given angles. Then work out the values of x and y. You must show your working. Do not use trial and improvement. So for x and y, we know that this is 2x. We know this is 2x. If we notice that HJF is a triangle, and in this triangle, if I highlight this, all three vertices are touching your circumference, which means that this angle is the same as this angle. This is also 3y. And this is the same as this. That's 2x. So angles on a straight line add up to 180, which means one equation is going to be 2x plus 3y plus 98 equals to 180, which is 2x plus 3y equals to 82. That is one equation. Now for the other equation, if we notice, we have another triangle over here. LKJ. And for this, we have the equation 7y plus 2x equals to 180, which means 7y plus 4x equals to 180. So we can use these two equations, solve them simultaneously to figure out the value of x and y. So 2x plus 3y equals to 82. 4x plus 7y equals to 180. You can multiply the first equation by 2 to make the coefficient of x equal, and then we can eliminate x and find the value of y. So that's 4x plus 6y equals to 164. Subtract the two equations. 4x minus 4x is 0. 7y minus 6y is 1. 180 minus 164 is going to be 16. So y equals to 16. And then we can put this back into either of the equations. I'm going to put it back into this equation. So 2x plus 3 times 16 equals to 82. 2x plus 48 equals to 82. 2x equals to 82 minus 48. 2x is equal to 34 and x is 17. So x is 17 and y is 16. These are your values. Then for trigonometry, we have a sketch for y equals to sine x. We are given that sine 220 equals to negative k. We have to work out the values of x between 0 to 360, for which y equals to k. So which means it's going to be somewhere over here. So if sine 220 is negative k, sine 220 is, this is 220 angle. So which means this angle is going to be 220 minus 180, which is equal to 40 degrees. So we have to find where k is positive. So k is positive over here and over here, because k is the value of y and y is positive above the x-axis. So it's sine 40 and sine 140, because this angle will be 180 minus 40, which is 140 degrees. So the values of x where y equals to k, where k is positive, it's going to be 40 and 140. So for this, you need to know where your sine is positive, where it's negative, where your cos is positive and negative, where your tan is positive and negative. If you don't know, remember that all are positive in the first one, sine is positive in the second one, tan is positive in the third one, and cos is positive in the fourth one. That's how you can figure it out. Then it says work out the values of x where x is between 0 to 90, for which 3 tan square x equals to 1. So 3 tan square x equals to 1. That means tan square x equals to 1 over 3. Take the square root. So root of 1 over 3 plus minus. So if you remember special triangle, 60, 30. If this is 1, this is 2, this is root 3. So for us to have tan x equals to 1 over root 3. That means it's going to be tan of 30. Why? Because this would be the opposite then, and this would be the adjacent. That would give us 1 over root 3. Root 3 over 1 would be tan of 60. So which means the value of x would be 30 degrees because it's asking for the range of 0 to 90. And for the range of 0 to 90, we only get x equals to 30. So special triangles are very important for the trigonometric questions. You need to memorize those triangles, or you can just memorize the values, whichever works for you. If you're someone who doesn't know the values, I'm attaching a link to one of the shorts that I've made that focuses on all of the trig values, and it gives you a trick which you can easily use to learn the exact values for the trig ratios. Then the curve y equals to ax cubed plus bx squared plus 7 has a stationary point at negative 2, 11. We need to work out the values of a and b. So let's first differentiate it because stationary points have a dy by dx of 0. So that's going to be 3ax squared plus 2bx. The derivative of a constant is always 0, so we don't write anything for the constant. Now we put dy by dx as 0 because once again at the stationary point the gradient is 0 because that's the turning point. So 3a, x is negative 2, replace x with that. And you'll notice we have an equation just in terms of a and b. So 12a equals to 4b and 3a equals to b. This is one thing. Now, obviously, this point lies on the curve as well. So we can substitute that, replace y with 11 and x with negative 2, and we'll have another equation in terms of a and b. So 11 equals to a times negative 2 cubed plus b times negative 2 squared plus 7. That's 11 equals to negative 8a plus 4b plus 7. Now b is equal to 3a, so let's replace b with 3a. That's going to be 11 minus 7 equals to 4a. 11 minus 7 is 4. So a is 1. For b equals to 3 times a. So b is 3 times 1, and that's 3. So this is your answer. Then the next question says that y fits the graph of a cubic function. When y is less than 0, x is less than 5. When y is greater than equal to 0, x is greater than equal to 5. The function is increasing for x less than negative 1, decreasing for negative 1 to 2 for x, and increasing for x greater than 2. We have to draw a possible sketch of y to f of x for values of x from negative 2 to 6. Since less than negative 1, it's decreasing, so it can go down like this till negative 2. Then from negative 1 to 2, it's decreasing. So that means it's down till 2 over here. And then 2 onwards, it's increasing. So it's increasing and it's crossing at x equals to 5. So you can see that's from negative 2 to 6 as they asked us. Less than negative 1, we can see that values of y are increasing. Then negative 1 to 2, the values of y are decreasing. Then 2 onwards, it's increasing. And it also said that for y is greater than equal to 0, for x greater than equal to 5. So as it crosses the x-axis, and as x is greater than equal to 5, y is also increasing. And beneath it, it was decreasing as is shown for the values of y, they are negative. Then we have to solve this inequality, which is 2x squared plus 4 greater than 2x minus 3 times x plus 1. So first we expand the bracket on the right-hand side. So that's going to be 2x squared plus 2x minus 3x minus 3. That's going to be 2x squared minus x minus 3. Collect the x squares on one side. So 2x squared minus 2x squared, bring the x over here as well. And we can take the 4 to the other side. So that's x greater than -7, and that's your answer. Then it says Miriam's date of birth is 14 September 2006. She makes a 4-digit number code using digits from her date of birth. The 4-digit number she makes must not start with 0 and have all different digits. How many codes can she make? So we have 4 slots, 1, 2, 3, 4. They said that the first number cannot be a 0. So the digits we have are 1, 4, 0, 9, 2, and 6. So if the first digit cannot be 0, that means we're left with 1, 2, 3, 4, 5 numbers in total. So we have 5 options for the first digit. Then for the second digit, we can have a 0, but now there's one less digit because we already used one digit over here. So we again have 5 options because now the 0 is included. But since we used 1 in the first slot, so it's from 6 to 5 now. Then again, 1 has been used from these 5 bits, so we're left with 4 options. And then again, 1 has been, so we're left with 3 options. So we times these numbers. So that's going to give us 300. That is your answer. Then show that 4 cos square x plus 3 sine square x minus 4 over cos square x is the same as negative tan square x. So for this, I'm going to use an identity in the numerator. The identity is that cos square x plus sine square x equals to 1. So I'm going to make sine square x the subject. So sine square x equals to 1 minus cos square x. So replace sine square x with cos square x in the fraction. So 4 cos square x plus 3 times 1 minus cos square x minus 4. This is divided by cos square x. Expand the bracket. 4 cos square x plus 3 minus 3 cos square x minus 4. Again, over cos square x. 4 cos square x minus 3 cos square x is cos square x. 3 minus 4 is -1. So if 1 minus cos square x is sine square x, then cos square x minus 1 is negative sine square x. So negative sine square x over cos square x equals to negative tan square x as shown in the question. So that's how you prove it. Then, in the next question says that the curve y equals to 2x cubed minus x squared minus 32x plus 16 has an x-intercept of 1 over 2. Use this information to find the other two x-intercepts. Now, in the 2024 paper, they did give factor theorem a lot. So it might not come this time, but to be on the safe side, it's best to practice one question to make sure that if they give it again, you know how to solve it. So x equals to 1 over 2 is a factor of this curve, which means if x is 1 over 2, 2x equals to 1 and 2x minus 1 equals to 0. We can divide the equation of the curve by 2x minus 1 to find the other x-intercepts. So 2x minus 1 divided by 2x cubed minus x squared minus 32x plus 16. Remember, if they give you a cubic equation or any equation where the highest degree of power of x is more than 2, you can easily use long division for factor remainder theorem to figure out what the other intercepts are going to be, given that one intercept is given. Or you can use like trial and error to figure out one intercept and then use that to find the remaining intercepts. So what can you multiply with 2x to cancel out 2x cubed? That's going to be x squared. 2x times x squared is 2x cubed. Originally the sign is positive, we make it negative. So that's 0. Then x squared times -1 is negative x squared. Change the sign again. So negative x squared plus x squared is 0. bring the negative 32x and 16 down as it is. Then what can you multiply to 2x to get rid of the negative 32x? We can multiply negative 16. So negative 32x, again change the sign. And negative 16 times negative 1 is positive 16. Again change the sign. So that gives us 0. So no remainder. So 2x minus 1 times x squared minus 16. X squared minus 16 can be factorized using difference of perfect squares, which is x minus 4 times x plus 4. So your other two x-intercepts are x equals to 4 and x equals to negative 4. If you're using long division for polynomials or remainder factor theorem differently, you can use that. That's completely fine as long as you're getting the same answer, like I've said before. Methods can be different for some people, but the main goal is to get the right answer. And with that, we're done with this predicted paper. If you have any questions or confusions, leave a comment below and I'll try to help you out. Best of luck for your exams, and I hope this video helps you in your exam prep. And do let me know once you're done with the exam what came and what didn't, and whether this predicted paper was helpful for you or not.